Fiber to the home. This is the third access net technology. Unlike the previous two, where we kind of exploit certain existing infrastructure, telephone network or cable TV network, this one here builds its own network. And because the cable are all optic fibers, so it's called a optic network. And it's essentially the internet service providers, if they want to allow users to access internet using FTTH, they will have to go out there and build these optic links into the civil infrastructure. So there are physical contact, okay, through some cables between the central office to home. And so you see in this example, it's very clean between the central office to each household, just optic cable, optic cable. Right. The only slight complication and boxes that are a little unfamiliar to you are these. First, optical line terminal, optical line terminal. So this is a dummy device. What it does is just to collect signal and then convert them into digital bits. Okay, so that these internet data can go on natively through the edge router and out to the internet. Now, what's a little bit more interesting is this box, the optic splitter. We've seen this term, splitter, the third time. Yeah, at the physical level, these splitters are essentially the forwarders or the switchers. Okay, so signals gets forwarded to the right destination at this point. And signal gets multiplexed also so that they can go on further upstream. Okay, so splitter plays the role of demultiplexing signals so that it reaches a particular household, or multiplexing signals so that it goes to the central office. So its role is a little bit like the routers or switches at the core of the internet. So optic splitter here is a very important device for the optical network. In this example, we see there's only one level of it. In practice, there could be multiple levels, so that you could have a regional optical splitter, and then you could have another splitter here inside the building in case there are multiple households in your building, okay, also subscribing to the optical service. Now, these splitters, depending on the mechanism that's running in it, okay, depending on the design, could work differently. Okay, so two typical architecture for these splitters are these, PON and AON. So passive optical network. What it meant is that what's being done here is very straightforward. You just have mirrors so that you can reflect signals so that they go on the right direction to the destination. There's no signal amplification. But if you use active optic network splitter, yeah, these signals get splitted and amplified before they get passed on further. That is very necessary in case there are multiple levels of splitters along the way. As a signal, as it travels longer distance, even though it's optic signal, it still decay. Okay. Now, in FTTH, yeah, the downstream or upstream bandwidth vary, but essentially the maximum capacity is much higher than the cable modem network, than the DSL network. Okay. In Taipei, very typical, you subscribe to services that's downlink 100 megabits per second, uplink 40 megabits per second. Okay. If you have special need, for example, if you are hosting web servers, then you might subscribe to 100 megabits per second downlink and 100 megabits per second uplink as well. Okay, so it can be symmetric, it can also be asymmetric in terms of the bandwidth in going in different directions. So essentially much higher rates, and it really depends on how much you can afford. Right? And nowadays these fibers can also carry telephone or television services. Okay, think about video on demand, So that is to carry TV programs through FTTH. And digital phone, okay, IP phones are one example. The trend is going towards that's just move to FTTH and then abandon the older legacy technology such as telephone, such as cable TV. So all content, including data, are transmitted over the one and only internet. One ring to rule them all.